Welcome dear students to this program. Dear students, today we are going to discuss from class 9 mathematics book on chapter 10, that is circle part 6. Dear students, today we are going to discuss about angles subtended by an arc of a circle. So before going to discuss about this angle subtended by an arc, let's understand what is angle subtended by an arc. You see, if you take two equal chords, what can you say about the size of the arcs? Let's have a look at this figure. Here we have two chords PQ and RS. These are two equal chords. And if we cut the RS, cut the circle from RS and we superimpose it on the minor arc PQ, then we can see that both will match. What do you mean by that? Is only their length equal? No. In this case, they are congruent. So, if two chords of a circle are equal, then their corresponding arcs are congruent, and conversely, if two arcs are congruent, then their corresponding chords are also equal. Now you see, here you have a picture. As you know, PQ is a chord and both the endpoints are joined to O. So the angle POQ is said to be the angle subtended by the chord PQ. Also, we can say that this angle is subtended by the minor arc PQ. On its opposite side, the major arc also subtend an angle, that is reflex of angle POQ. That is, we can say the angle subtended by an arc at the center is defined to be angle subtended by the corresponding chord at the center. So as you know that the minor arc subtend the angle and the major arc subtend the reflex of that angle. Now let's have a look at this figure. Here in this case, here the minor arc PQ subtend angle POQ and the major arc PQ subtend the reflex of angle POQ. Now see, in this figure we have two equal chords, so we have two congruent arcs. As we know that two equal chords subtend equal angles at the center, so we can also say that congruent chords subtend equal angles at the center. So here congruent arcs or equal arcs of a circle subtend equal angles at the center. Is there any relationship between the angle subtended by an arc at the center and at a point on the circle? Yes, the relationship is stated by this theorem. The theorem states the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Let's have a figure. You see, we can have these three cases. In first case, the PQ is the minor arc. In the second case, PQ is the semicircle, and in third case, PQ is the major arc. So in this case, first case, POQ is the angle subtended by the minor arc PQ, and A is in the rest part of the circle. So PAQ is the angle subtended by minor arc in the rest part of the circle. Similarly, if PQ is the angle subtended by semicircle, then its opposite side, the rest part of the circle is also a semicircle. So here in this case, POQ is the major arc and the angle subtended at the center is reflex of angle POQ and its angle on the rest part of the circle is PAQ. So by taking any one of these case, we can prove, and it is also true for each case. Now you see, in this case, we have PQ as the minor arc. So what is given here? The arc PQ of a circle subtending angles POQ at the center O and PAQ at a point A on the remaining part of the circle, as we discussed earlier. Now what to prove? We have to show that POQ, the angle POQ is twice the angle PAQ. Now to prove this, we need a construction. What is the construction here? Let's join AO and extend it to a point B. Now let's have the proof. In this case, all the cases, you see BOQ is the exterior of the triangle, that is AOQ, and we know that the exterior angle is same as the sum of the interior opposite angles. So angle BOQ is equal to angle OAQ plus AQO. Now you see the condition is due to this, that is an exterior angle of a triangle is equal to the sum of the two interior opposite angles. Now you see, in this case, in triangle OAQ, we have OA and OQ are equal. Why? Because they are radii of the same circle. So, as you know that in triangle, if two sides are equal, their opposite angles are equal. So we get OAQ angle is equal to angle OQA. Now, if we consider the previous one, that means we get that angle BOQ is equal to twice the angle OAQ. Let it be the equation 1. Now, similarly, we can also prove that this angle BOP is twice the angle PAO or OAP. Here, this is the equation 2. Now, if we add these two, what do we get? We get angle BOP plus angle BOQ is equal to twice angle OAP plus twice angle OAQ. So by taking 2 common, we have OAP angle plus OAQ angle. Now what is BOP plus BOQ? See, BOP and BOQ constitute the angle POQ. So we can write that angle POQ is equal to 2 into OAP plus OAQ constitute the angle PAQ. So we can write POQ is equal to 2 PAQ. This is our proof. The minor arc, what we can say for PQ as the major arc, what can we say? That it is reflex angle of POQ. This is reflex angle of POQ, that is its value is twice the angle PAQ. Now you see, in this case, if we join this P and Q, we get a segment. If this is the segment, we have two segments, one is major segment and another is minor segment. We can say this angle PAQ is angle subtended by PQ in the segment. Okay? Now, this is the angle in the segment. Now you see, angle subtended in a semicircle is a right angle. If we look at this figure, as you know that PQ is a diameter, it divides the circle into two halves, that is two semicircle. if we consider one is to be arc and the rest part is also a semicircle, so POQ is 180 degree. The angle subtended by the semicircle is 180 degree, and inside it the angle in the segment, that is inside this semicircle, is half of it, means half of 180 degree, that is 90 degree. So the angle subtended in the semicircle is a right angle. So it is said that angle subtended in a semicircle is a right angle. Now you see, in this figure we have, apart from A, we have another point C on the same segment. So what about the angle subtended by PQ minor arc at the rest of the circle? If we take any other point C on the remaining part of the circle, what is the relationship between the angle subtended by arc PQ at A and C? You see, in this case, this relationship is stated by another theorem. The theorem states that angles in the same segment of a circle are equal. Now you see, if the angles on the same segment are equal, then how to prove this? Let's see. Here is the figure. PQ is the minor arc and rest of it is the major arc. A is a point on the major arc. C is also another point on the major arc. So what is given? Here O is the center of the circle and PAQ and PCQ are the angles in the same segment of the circle. So what to prove? We have to prove that these two are equal. So we can write that angle PAQ is equal to angle PCQ. To prove this, we need a construction. As earlier we learned that the angle subtended at the center is twice the angle subtended at the rest part of the circle. So to use this, we need a construction. So here the construction is join PO and QO. Now the logic says that if POQ is the angle subtended by minor arc PQ and PAQ is angle subtended in the rest part of the circle, then what is the relationship between these two angles? The relationship between says that angle POQ is equal to twice the angle PAQ. Let it be equation 1. Let's have the same situation for the angle PCQ. So we can say that POQ is the angle subtended by the minor arc PQ and PCQ is the angle subtended in the rest part of the circle. So we have the same condition that POQ is equal to twice the angle PCQ. POQ angle is equal to twice the angle PCQ. Let it be equation 2. Now if we compare these two equations, we can see that on both the equation we have POQ on left side. So the right side must be equal. That means PAQ is equal to PCQ. So by getting this, we proved that the angles subtended in the same segment are equal. Now you see, here is one of the application. The question says, in the figure A, B and C are 3 points on a circle with center O such that angle BOC equal to 30 degree and angle AOC equal to 60 degree. If D is a point on the circle other than the arc ACB, find ADB. So let's see. This is the given circle. O is the center. This angle is BOC is 30 degree and AOC is 60 degree. So given angle BOC is equal to 30 degree and angle AOC is equal to 60 degree. Now the arc ACB and rest part of the circle is the major arc ACB and D is a point on it, and it is given that ADB is angle subtended by arc AB on the rest part of the circle. So you see AOC and BOC are adjacent angles. So sum of these two angles, that is angle BOC plus angle AOC, is equal to 30 degree plus 60 degree, and sum of these two angles is same as angle AOB. So we can write angle AOB is equal to 90 degree. Now you see AOB, this implies angle subtended by arc AB, say ACB, at the center is equal to 90 degree. So the angle subtended by arc ACB on rest part of the circle by arc ACB on at a point on rest part of a circle, say at D, is half of it. That is angle ADB is equal to half of angle AOB. That is half of 90 degree is equal to 45 degree. So the measurement of angle ADB is 45 degree. Dear students, today we learned about the angle subtended by an arc and the angle subtended by an arc and the angle subtended by an arc at the center and at the rest part of the circle and their relationship. I hope you understand all these discussions. Have a good day. Thank you.